Hello everyone, this is Debandya, and this is the first project for AI product management, which is from Duke University, and this is about machine learning foundation for project managers. So let's have a look into it. So this is about the starting point, the where we started the project, and this is about a set of data that we were provided with, and we were given the x variables and the y variables. The x variable in this particular data was about ambient temperature, the exhaust vacuum, the ambient pressure, and relative humidity. And the y variable was the target P, which is the net hourly electrical energy output. So overall problems that we need to solve here was about defining the machine learning algorithm, the correct machine learning algorithm to predict the PE, and also to select an appropriate output metric to evaluate the performance of our model. So let's get into the first part of this project, which was about machine learning approach that we took and the appropriate output metric to evaluate the performance. So machine learning approach, based on the data available, we can very confidently assume that there is a linear relationship between the features and the target. And we did an experimentation about that, and we're going to see it in the next slide. Therefore, a supervised learning algorithm based on linear regression is something which would be an appropriate choice for the same. So the output metric to evaluate the performance, mainly the R square, but also we have taken MSE, which is the mean squared error, and mean absolute error, that is the MAE, to additionally support the decision that we take about this model. Coming to the second part of it, which was about determination of possible features to use in a model. So as we have already discussed, we are taking a linear regression approach on this. So we tried establishing linear regression with all the features that we have in here separately, and we can see it very clearly that the ambient temperature and the exhaust vacuum are the ones wherein we had the maximum R square value. When it comes to the ambient pressure and relative humidity, you can see that the R square values are fairly low. So this is a small experiment that we did with all the features that we have for establishing a linear regression equation. So in conclusion, we can see that the AT and V, which is about the ambient temperature, the exhaust vacuum, okay, these are the ones which were the most dominant feature in establishing the relationship, and it can already be assumed that with these two features itself, we can create a very good model. Okay, just for our knowledge, we are going to call ambient temperature as AT, exhaust vacuum as uh, EV, ambient pressure as AP, and relative humidity as RH from now on for a better understanding of the project. Coming to the third part of it, which was about defining the model. So we basically created three models, which was the first one was about AT and V and AP and RH. That is all the variables, taken all the variables into consideration. Then we created another model which was having the three variables, x variables, which is AT, V, and AP. And the third one was AT and V. And in the the data which were provided to us, we took a training set which comprises of the 80% of the data. Validation set had 10% of the data, and the test set had 10% of the data. So if we see the coefficients and the intercept value that we have received for all these models, for model 1, these are the intercept values. Okay, this is for model 1, this is for model 2, this is for model 3, and the coefficients for each of it, each of the x variables that we have in here. Okay, we'll see the R square value in the very next slide. So here we go. So this data we have already seen. This is about comparing the models. So when we're comparing the model in our validation set, we saw that the R square value for the model 1 was having 0.92, For model 2, it was 0.91, and for model 3, it was 0.91. Okay, and yeah, but the values were different. So, but then when it comes to MSc and MAE, we, uh, as we said, that we wanted to, uh, reconfirm with these two values about the mean square error and mean absolute error. Here also we see that the MSc for model 1 and the MAE for model 1 is the least among both of it, wherein the R square value is the highest compared to the rest of the two models. So we can clearly say that model 1 is the best one that we have in here, although every model has given very good result. But since this is the best that we have in here, since we are going to go with this model, which is model number 1, okay, comprises of all the X features that we have in here, which is AT, V, AP, and RH. Okay, so finally, when we took this model to test our final, test set, we got the R square value as 0.92, the MSc as 20.55, and the MAE as 3.66. The results are in line with the metrics defined with the validation set. All right, this is the validation set. So we went with the model number 1 for testing our data, and these are the values that we had received. All right, so we could clearly decide that we were going with model number 1, which is having all the features available, which is AT, V, AP, and RH. Thank you so much for listening to me. I wish you all a great day ahead. Thank you so much.